Good morning, everyone. Well, it looks like it is time for our webinar to begin. I want to thank you all for attending. I think we've got a very exciting topic today that hopefully everybody will get a lot out of. We will be talking about PCB123 today. We have a guest speaker, Mr. Bob Tise from EMP Shield, who is a longtime PCB123 user and has supported the tool when he was a Sunstone employee back a couple years ago. Got a lot of experience with the tool and has been around it for quite a while. So we're pretty excited to have Bob here to share some wisdom with you that he's learned over the years from PCB123 and PCB design in general. We've got a pretty full agenda today. We'll be talking a little bit about PCB123 as a tool. Bob's got a live demo planned where I think he's going to try and make probably a simple, but actually do a build a board right before your eyes. Talk about some parts modifications and schematics and layouts, etc. If there's any questions that come up during the presentation, if you wouldn't mind putting those in the Q&A section of the Zoom app, that would be great. We'll try and answer as many as we can in the Q&A part, as well as live for those that make really good sense. So with that, I will give the reins over to Mr. Bob Tise and allow him to wow you with his PCB123 knowledge. Bob, welcome.
Welcome. Good morning. Just as kind of an introduction, my name is Bob Tise. I work for EMP Shield. That's a Kansas company that builds pretty high performance surge protection for home and industry. We're got a great product, and we're designing about one or two boards every couple of weeks, going through and making changes, new product, whatever. But I'm in the tool, the PCB123 tool, quite a bit, and I've been doing it for, oh heavens, a little over 15 years now, and I kind of enjoy the tool. It's a fairly easy tool to learn. Well integrated into PCB or Sunstone circuits manufacturing processes, so that it's really hard to break your board and make something that they can't build, so long as you follow the rules and keep the errors out. And I'll talk about that downstream. What I plan to do today is just basically put together a board, fairly simple, with very little functionality built in. Just throw some parts on and go and make modifications to a part or two, just to show you how that works, and talk about the thought that goes into doing that. I'll show you how to find parts at DigiKey, which is a big part supplier that you might use either to research parts, research availability, or just order parts in limited quantities or massive quantities. They pretty much do that. But there are other parts suppliers out there, but that's just a handy one. And if you have any questions, just throw them on. We'll try and either answer them on the fly or hang on until the end and make something up as we go. And on that note, let's get started. I'm going to start out by just deleting all of this because I'm going to do it again. There's a couple different design paradigms that you can go through. You've got your hobby user to build things in the garage, and you've got your professional user, somebody that's works for a corporation and wants to do a well-documented and a well-supported design that can be leveraged or used later by another designer, and easily found and modified by the team. downstream, whether whether I'm here or not, somebody could go into my designs, read the schematic, figure out what's going on, and make a new one. If you're just building something in the garage, you want to make a resistor to circuit to slow down slow down the timing in your car, and you know what you want to do. You just you throw a couple of parts on the board, you make a board, and you wire it up. You're only going to do it once. It doesn't matter if it's well documented or you can. Audio is horrible. I'm sorry about that. I'm trying. And I'm lost. So it doesn't matter if your design is easily trackable or whatever. You're only going to make a couple of them. So you just do something, and just like working in your garage, you just make it and move on. So we're going to talk more about the professional aspect of this process, something that you can actually document and save and go back to revisit later. So to start out, we'll start from scratch. So I open the tool, it's on the screen. I want to open a new design. You can tell it, give it a name.
Hey, Bob, can you zoom in a little bit so we can see a little closer what you're doing?
I don't really have, I can't make the thing bigger. As big as it's going to get. So I opened a new design using the new design button. I called it new design. And I told it I want it to be 5 inches by 3 inches. Let's do that again, just for giggles. New design, 5 inches by 3 inches, that's the default size that comes up. You can change that to whatever you want. And you can import a net list if you have something from your engineer that is going to work. Otherwise, you just start in building your schematic. It's a 2-layer board. You can have 2, 4, 6, or you can make more. There is a trick to do that. You can define inner layers as plain layers to make them, a power and a ground layer if you want. Tell it how much silkscreen you want. Just define all the options, the thickness of the board, the amount of copper, and how quick and how many. You don't have to make that decision right now, but it just comes up with a default. Say OK to that. Boom, there's your board. 3 inches by 5 inches. It creates your fab drawing right off the bat. Gives you a title block and a drill chart. Right now there are no drills, but those will update. You have to update this as you go. I don't really have anything in the board right now, so just to give you a picture of what's going on in the schematic, it's the same thing. You've got a schematic. This is where you define your circuit and you make your inputs and outputs and connectivity, and you can make it neat and tidy to go with what's going to be on the board. But it's a little easier to follow a schematic than it is to just throw parts on and start hooking up on the board. You can keep track of the directional flow of the circuit a little bit more accurately in the schematic. I'm going to throw down some parts. I'm going to go with a 10-pin connector. Just to start off, and I'm not going to be too picky about the one I picked because I don't really plan on building this. I just did a 2x5 connector right off the list. It's a part that's available in the system. I'm going to put one on each end. I'm just going to put one. Hit escape to get out of that. I'm going to throw a couple of diodes, the LED, red LED, surface mount part. I like that. Okay. I'm going to put a resistor because What goes an LED without something to hook it up to? And I like 1206s because they can use. I want to give it some power. We'll call this 5 volts. And ground. That's analog ground. No ground will do. And we'll give it a couple of these. Control C is copy. Control V is paste. And we can add a couple of those. It automatically increments the reference designators on the parts, so you don't have to worry about having duplicate part numbers. It won't let you have the same part number. So if I wanted to make another R1, it won't let me do that. And it keeps track of things as you go through the design. You can easily find parts as you go. The bill of materials is constantly updated. It gives you not only the number of parts, it gives you the part number, the DigiKey part number, so you can easily find the DigiKey and order these parts using the bill of materials as you go. And it keeps track of the price. It doesn't have the price of the parts individually listed here for whatever reason, but check pricing. And it found some below, it didn't find some of them. That's a nice feature. If you know for a fact that the parts are available at DigiKey right now, then it will give you the parts. So I tend to, before I just throw on parts on a board that I'm working on, I'll go to DigiKey, find the parts, make sure that they're available, make sure that they're not going to be obsolete, and then put them on the board rather than just put a whole bunch of parts and hope I can find them later. That's the best practice, I think. When you're putting your parts on, you can use the crosshairs on your screen to line them up, rather than having, if this part was over here, it would be, just visually not as tidy as having them lined up. Again, style points, that's about all they're good for, style points. Then you just click and drag. Pick up your, just to give you something to work with in the circuit board when you get these parts in the layout view. And again, this isn't going to do anything. I'm not going to actually make this board, but now we have some parts to play with. Go over to the layout view, throw the parts on the board. You've got, sometimes when you go to click on something, you'll click on something and it'll select something you don't want to click on or select. So if I'm grabbing parts in the corner and I accidentally grab the board layout or the board outline and change the shape of the board. So I go over to the select filter, turn everything off using the red button, and then say I just want to be able to pick components. And then all I can select is components. That no longer accidentally select the board outline. And if I've got a lot of parts, sometimes they get hard to find, and I want to just immediately find R1, type an F for find, and then type R1, and and there's R1. It said you can do that for any part of your board. You just have to know who you're looking for. It's an easy, quick and easy way to get the thing put together. Line them up, you know where you want them. A lot of times you want to put your parts on a specific grid location. So you've got a housing that they're going to fit into, and you want this LED to align with a hole in the housing. You just go to Properties, go up, right click to get, put your mouse over the part, right click, Properties, and then over in the X and Y location, I want to put this at 2 inches by 1 inch. And I want to rotate it 90 degrees. And why do I want to do that? Just because it's Tuesday. I hit apply, and that part is now exactly where I want it and rotated the direction I want it. The other way you can do it is set your grid and set it to 0.1. Okay. And but you want your grid to be coarse enough that you can easily line things up, put them where they belong. R is rotate, so you want to rotate the part. Standard increment is 90 degrees. You can change that. Let's say that I want to clock these around a circular board, and I want to have each, a bunch of these at 15 degrees. You go up to View, User Preferences, and say Rotation Increment. You want to change that to 15 degrees. Say OK. And rotate 15 degrees at a time. Those are some handy features that you can play with. I've done a few boards that had that sort of orientation going on, and they seem to work. Place your parts again how you want. And then in order to connect your wires, you go back in, change your select filter to wires. Because you don't want to be, once you get your parts where you want them, you don't want to be moving them around and doing a lot of well, my grid is so coarse that I can't find that part. So I want to set my grid. Now I can find my part, finish that route. And I'm just routing with the standard width, but so this wire, you just put your mouse over the wire, it'll tell you that it's an 8/1000 wide wire, and I want to change that because it's going to carry, I'm going to carry current, or just want it to be more robust. I tell it, change the track width. I can just change the segment width using the W button, and it'll just change the one segment on the line, or I can change the track width. Go in there and I say I want this to be 0.04 instead of 8/1000, so I got 40/1000. Now I got a nice fat wire. It'll carry a lot of current, have low resistance, and that'd be cheaper to build. You can also change the net width, but if you've got, let's say I want to wire this up here.
Hey, Bob, we've got a good question that might go well here. Can the silk screen be rotated independent of the part?
Oh, yeah. So back to the select filter. Let's turn off Let's talk about the select filter. You've got wires, you've got parts, you've got text, you've got polygons, and you've got pins. And you can set either, any one of those. You can set the, combinations of them, or you can just select them all. If you want to select them all, set the green. That'll make everything selectable. If you want to just select text, turn everything off, say text. And I want to move text around, makes it easy. Put these like so. And I've got assembly text, and I've got silkscreen text. The silkscreen is white, and assembly is blue. So I want to rotate these guys. I can either click on properties, then rotation is 0 degrees, and I want to make it 270. And then, or I can rotate. Just hit the R button. And since it's set up to 15-degree standard rotation, it will just keep rotating. So now that I've got text rotated every which way, we'll go back and finish routing this board. There is an auto route feature. I tend to not use it because it does things that I don't enjoy. But let's go and do that. So just design auto route, and it will go in and fail one connection. Didn't like. Again, it does strange things. It does. It is a good way to go on, Bob. It's a good way to figure out if you've got enough room on your board to actually route everything. So sometimes I'll have a board and I'll wonder, gee, will I have the ability to wire this up? Is there enough room on the board to do it? So I auto route the whole board just right after I finish placing my parts, and if it gets close, I'll know that there's enough room for me to go back, delete all of the auto route stuff, and finish hooking up, or route the board manually. And I would never do a board. I would never do a board from scratch and auto route it and just take the results, because it's, number one, it doesn't look good, and number two, you're not entirely sure if it did a good job, if it completed, if it's gonna work. I want to control line widths. I want to control angles and connections. I want to control things like where the board, where the wires go into the part, so I don't have these acid traps, these acute angles at the connections. I'll make that wire bigger in order to get rid of those acid traps. Got my select filter. And then you don't have, what happens is when you manufacture a board and you've got these little angles, chemicals get trapped in these little angles, these little pockets, and it's really hard to get them clean. So later down the road, you can get some corrosion at these points, just because it's impossible to get all of the chemicals out of there, and it can cause reliability problems in your boards downstream. So you don't want that. You can either route it to get rid of them so that it's completely gone, or you can just change the width. Route straight in like this is a good paradigm, versus going in at an angle. Sometimes you don't have an option; you have to go in at an angle. Other than that, that's kind of the thought process that I go into when I'm routing these things. Now let's go in and say this.
I got another question for you, Bob.
Does the grid change remain constant after change? Until you change it again. Just say G for grid, and I want to change it, and it could go. It helps to route. I like to route on a 5 mil grid or a 5,000 inch grid. It just works out in my head better, and I get a good result on my wires. It's easy to keep your lines straight. It's easy to keep your corners kind of congruent and your spacing even with a constant grid. You can change it if you're routing with a a big wire like this. You're routing 40 mil wires. You can change your grid to 20 or 40 mils so that your wires come out with consistent spacing. But let's just say I want to change this net width to 40 thousandths, and then I want to route this wire. You see it pops an error if you get too close. So you just put it right up next to the wire here, and you have an outline that you can follow to space your wires nicely. And you'd never do this. This is nothing you'd ever route like this. But you can. If you're doing differential pairs, high-speed wires, you can route together like that, and the spacing remains pretty constant. And these wires are, I don't know what the default setup was of the spacing on these wires, but it's easy to find. Properties, default spacing on nets. Trace width is 40 thousandths. Copper to copper is 6 thousandths. So it won't let you route any closer than 6 thousandths to the next trace, otherwise it throws an error. If it does give you an error, it's easy to go back and fix it. It's easier to go back and fix it when it pops up rather than wait until you get a pile of them and then go back and try and fix a whole bunch of things that are wrong. You may not have room to do it at the end of the design, versus doing it up front. And then I'm working along, and then I decide, gee willikers, I've got too many pins on this connector. It's going to take too much room on my board. This connector costs a lot more than, say, a 10-pin connector or an 8-pin connector. I want to change this part. You can either go get another library part and place it in here, or if you just want to change this part and make a new component out of it, that's another option. And let's say an 8-pin connector is not available from this manufacturer or from DigiKey, but you need one, or you're going to trim. It's a part that you just trim a bit off of it. So you say, okay, set my FLET filter to parts. I'm going to go in and say, edit footprint. That's this right here. You get a whole new window, and that's just a footprint window. And you say, okay, so I've got pins are spaced. So let's go for the pins. Pins are spaced. Properties. Where's my origin? Use pin and origin. Now I can find that information. That 0.1 inch by 0.1 inch, which is great. I just want to delete 2 pins. Okay, we're going to make this an 8-pin part. Set my grid. Get the grid visible. First, let's do this. I'm going to change the board size. And you can, if you know how big the part is and how big you want to make it, you just set the grid to do that. But this part's now going to be smaller. By some amount, about 0.1. And since there's a drawing layer and a silk screen layer, go in and change all of those to be in the right spot. And it's, again, I'm just doing this as an example, so I don't calculate lengths and widths and sizes. Just made it about the right size by eyeball. Then you would say file, let's save it using just the disk button. I'm going to call this given custom samples. You can name a new design if you want. If you want to keep track of your parts, I would always say let's make a custom. In the custom folder, I would make a connectors. You could even say this is a Molex connector. You could say Molex connectors.
Hey, on that topic, Bob, can you import custom board shapes or custom part shapes?
You can get, there's a company, SnapEDA, that will make, that has a huge library of PCB123 parts. Also, just about any other CAD tool you could ever want. That you can go, and if they have it, you just import it. If they don't have it, you ask them, and they'll build it for you. They charge, I don't know, it's 20 or 30 bucks to build a part, and they just make it for you pretty darn quickly, and have that available. You can check it if it's not right. It's always best to check the parts. But if it's not exactly what you're looking for, go back to them and say, hey, this part looks pretty good, but it needs this other pin. The holes are too small, or the holes are too big, or the pads are too small, and they'll make that adjustment for you, and then you can import that part. I can show you how to do that. It's pretty simple. You just download it, drag and drop, and off you go. Custom board shapes. If you have a board shape, you can import get out of this. The DFX import export. You can import a DXF or an IDF file, and if your DXF or IDF file is created correctly, and that all of the corners are congruent, and there are no overlapping lines, it will import a board outline for you. I've done it. It works. It takes a little fiddling sometimes in the DXF or IDF file. You can create that file in a Gerber editor, or if you've got a file in a Gerber editor, just turn off all the other layers and export to DXF your board outline. And if it's a good board outline, it will import correctly into PCB123. Also in PCB123, it's pretty easy to modify your board outline if you know where the corners are and what you want to have happen. I've got this 5x3 board. If I wanted it to be L-shaped, set my grid to point, some coarse enough thing that it will line up, or to a specific size. I want this board to be 2.5 by 3 inches. You just set your grid to 2.5 by 3. Say OK. And I'll just grab this polygon. So select filter to polygon. Grab this corner. And it will be 2.5 by 3. It's not going to like it because my board now, or my circuit is off the board. But I can grab all the parts and all the stuff. That's going to hurt it, I think. Oh. It does like to snap things to grid. So to answer your question about does the grid stay the same? Yes, it stays the same, and it can get sticky. I mean, you saw it. If you try and move something, it wants to move it the grid onto grid. So I had to set my grid to a smaller increment to get the parts back on the board. Then when you do that, your fab drawing is wrong. You just say generate mechanical drawing. Oh, it redimensions your board. Reset your drill chart to tell now I've got 16 holes, 40 thousandth of an inch. 16. Where do I have 16 holes? That's a surprise, Matt. I've got 16 holes. What's going on here?
Sorry, I'm muted. I thought maybe that when you modified the part that it maybe doubled up the holes or something.
Okay. I made pins. That's fun. That's something to look into. And that's the first time I've ever seen it do that.
That's weird. There's another question on importing schematics if you want to field that.
Well, I created the schematic right here in the schematic tool in PCB123, and that's how I would recommend you do this. It's easy enough to do. It keeps your parts tied together and keeps your schematic and your board and your bill of materials all synchronized and handy. And you can go back and edit it quickly and easily. If you want to edit a schematic, you have to output a net list and then import that net list using the file import PCB tools, net list, prepare, update, design, and somewhere in there there's a way to import the net list. I haven't done that for years. I tend to not. It makes a design. It throws a lot of parts on your board. You have to coordinate the footprints with the schematic symbols. You can't read the schematic when it's all done because it just drops. It just drops a bunch of symbols like this tied to your parts. When I edited the footprint, it changed my symbol to a generic symbol and hooked up just basic net symbols to it. In order to get those to tie back correctly, I would have to go in, delete the symbols, hook up the wires, and clean up my schematic again. So I don't like to work like that. I don't like to change my footprints on the fly. I like to make a new part and place that part and wire it up on the schematic as I'm working. That way, I don't have a bunch of these named nets floating around that I can't track. You know, I'd much rather trace this 5 volts like that than to have a 5 volts symbol here and a 5 volt symbol here, and then maybe another one over here. I just wire them together and keeps the confusion down. Makes it easy for someone else to come back later and read it. You can have them check your work. Whatever you want it, whatever purpose you have for the schematic, you can have on meter project. And, you know, again, it's not a huge deal when you've got 4 or 5 parts on the board and power and ground. It's not a big deal. But when you get a design with, say, 100 parts on it, and it goes to 2 pages of schematics, or you want to change the page size, and you end up with a D-size drawing. It's 34 inches by 22 inches, and you fill that up with parts and symbols and wires. It gets a little harder to follow what's going on. So, will the recording be available to import schematics from LT-Spice? Again, you can import a net list from LT-Spice. It has to be in PCB123 or Tango format, I believe, in order to do that. So if you can output a Tango format, yes. So you've got all the board done. Let's say that let's say my board's all done, wired up, and ready to go. I've got it. You know, it's going to be again a 2.5 inch by 3 inch board. Total boards square inches, and tell me if I'm wrong, but most of the price calculation of a board is calculated on square inches, thicknesses, number of layers, and other features that you add to it. But the square inches, that's where the rubber meets the road on the pricing on these things. So you get it all taken care of. You want 20 boards in 3 weeks. It's going to be about $20 a board. And I said top and bottom solder mask. There's no solder mask on the bottom, so just let's go with top only, and then the price comes down a little bit. Everything that Sunstone has to do to build your boards, you're going to pay for it at some point or another. So you've got your board all done. You say, I want to order this guy. So you go up here and just click the order button. It does. You want to save it? I want to give it a name. File, save as. And it saves it in your documents folder by default. You can give it a location if you want to keep things in a certain project folder on your board. You can do that. I'm just going to hit save because I can. Then I say check the board. It says, got dangling traces, unconnected net errors. Oh, okay. I know they're there, and by Unity, I know what I want. I want these to be disconnected, so I'm just going to order it. You go in, you say order. It tells you the same thing again. It says, do you really, really want to do that? If you're the kind of guy that really, really wants to do that, rock on. Goes to Sunstone Circuits, gives you the order. It brings up the order form, and you can either order, just take the defaults, take all the defaults and say, I just trust that everything's exactly the way I want it. Or you can say, geez, I really wanted gold. Click on gold. and the price goes up to $30 because gold costs money. I want these to be in a tab route panel because I want to run it down my automated assembly line. I don't have any parts hanging over the side of the board. Suddenly your part price goes up, but you're going to be able to automate the assembly of this board and go through that. You can order any of these certifications or extra features. You can order assembly through Snap EDA. Say I want to, or I'm sorry, screening circuits. You can order a stencil. Any of these, either a prototype stencil where you'll just put a sheet metal stencil over an individual board, squeegee it on with a squeegee the solder paste on, and then use your toaster oven or some other method to melt the solder to your components. Or you can order these stencils that fit in your automated silk screen or automated solder paste machine, and it will fit your machine. Then at that point, you get your pricing. You say save a quote. You can put it out and give it to your purchasing people, and they'll have a quote to order from. Or you can just say add it to my cart and order. And since I don't have an account on this machine, I can't do that. But the order form is pretty simple to use. You go through, fill in your personal information, and order your boards. Would you see if this is compatible with PCB123? Matt, you've got a task.
Yeah, I see it. Yeah, we'll get back to you with an answer on that via email.
Okay. Other than that, let's go with questions now. We're down to, I guess I got the 5-minute warning.
All right. Anything else you want to impart upon us quickly, Bob?
Really, did I kill my 1, 2, 3 session?
That's still going.
Yeah, again, the tool makes it really easy to do your designs. It makes it easy to find parts. In your schematic, you can go into your schematic and say, I've got this part. It is a LED from Dialight. It gives you the DigiKey part number. I'm going to click on this and hope it goes directly to the part in DigiKey. It should. It did not. It doesn't work. What have I done?
An obsolete part or something?
I think it is probably an obsolete part. I just grabbed it randomly from the library, so. Oh, I see. I've got the part on the screen. But you go to DigiKey and you can look at the specifications on the data sheet. Use that to check your footprint, make sure that it's going to fit, make sure that it's a common part that they do stock and that is available. And let's try that again, just for giggles. Properties. All right. It'll find it. It'll find something useful. Sisters, service now. And if you want to find out if they stock it, and if you're gonna order parts, you want to click in stock and active. Those two buttons will get you a list of parts that you can actually buy. If you don't click those, you'll get a much larger list, but some of the parts will be either obsolete or you'll be manually looking through a bunch of parts that you can't even order. And then you can decide, what exact part you want by narrowing it down using their select criteria. 1206. Then it gives you just the array of parts. You got parts. These are pretty much all the same size. They're all the same value. Some are 5%, some are 1%. Some cost a lot more. Some cost a lot less. So you can use your search criteria to narrow that all down. Super simple, and it works for just about any part you could want to select. Back to PCB123. Somebody's got to have questions. Thanks, Matt.
We got a couple questions that we're gonna answer a little bit later. I think they'll take a little more time and in-depth answer than we can do live. Are there any other questions that anybody's got before we let Bob go? I don't see any others coming.
Everybody's gone quiet.
Yeah. Oh, here we go. How often is PCB123 updated?
That's a question for Matt.
So currently, most of the updates are doing kind of some simple bug fixes. Our main developer on that has taken some time off and is looking at retiring. So right now, the updates are kind of far and few between. Wow, that was weird. As we're looking to advance with a new developer down the road. So that's about where we're at this point on updates. There will be a recording of the Zoom of this presentation that does go out probably tomorrow. Once we get it cleaned up a little bit, it'll be sent out. And it looks like that's all the questions that we have for today. So thank you, everyone. I appreciate you attending. We will likely have Bob pick another topic and in September, and we'll do another 1-2-3 demo of some kind. And Bob can give us some more of his wisdom on 1-2-3 designs. So until then, have a great time, and we will see you guys next time.
Okay, yeah, thanks for watching, guys.